Alright, Common Core Algebra 2, so we're going to look now at 1.6, and this will be our part 2 for 1.6. Big difference now is we're going to be looking at what are called compound inequalities, and we're getting into define those in a minute. Same idea as our linear inequalities. We are both going to solve them today and then also graph that solution. So to start, a compound inequality is inequality that uses the union, meaning we have an or, the actual word or the intersection, meaning there's an and we don't see the word and, but we're going to use it when we say it, of two simple inequalities. So we have an example here. We would read this as 2 is less than or equal to x and less than 7. This would be an intersection, meaning x has to be both these things. It has to be greater than 2 and also at the same time less than 7. Here obviously is an or situation because we have the word or. X is greater than or equal to 5 or x is less than -8. Okay, so in this case it only has to satisfy one of these conditions at a time. And in fact, if you look at this example, x could never be both greater than or equal to 5 and less than -8. Okay, so a solution to the compound inequality is going to be any number that satisfies both parts, or in the or case, just one part. So the or is going to be 1 and the and is going to be 2. Numbers that satisfy this would be something like 3, because that is in between 2 and 7. We could say 5. Also keep in mind that we could have decimals. We could say something like 6.9. That is in between 2 and 7, where it's 6.9 is greater than 2. It's also less than 7. We could also say 2 because of that equal to piece, but we could not say 7 because it's strictly less than 7. Okay, the or piece, so numbers that would be greater than 5 would be like 6, 7. We could say 5 here because of the equal to piece. On the other one, or, we'd say -8. Think about your number line now. Getting more negative is to the left of -8. We could say -11. We could not say -8 because it's just less than for that piece. Okay, to actually solve a compound inequality, just like our simple inequalities that we did, but with an and inequality, we're now going to have what are like 3 sides. So we're going to do inverse operations, and the important piece is to all sides. So an example of that, if we look, 2 is less than or equal to 4x minus 6 is less than 2. Remember, dividing or multiplying by a negative still exists here. So when we say all sides, one thing you want to think about is there's a division through that piece and through that piece. So we have 3 different sides here. We're going to start by adding 6 now to all 3 sides. So on the left side we're going to get 8. I'm going to bring down my less than or equal to piece. This is a thing students forget to do. Make sure you're paying attention to detail. Bring that down. We're going to end up with 4x in the middle, and then bring down the other less than symbol. Again, paying attention to detail. And then bring down 10, because 4 plus 6 here is 10. Last step then, we're dividing by 4. And so we're going to have 2. I'm going to just write the answer up here for space. 2 is less than or equal to x is less than 2.5. So that would be the solution to that inequality, this compound inequality. So our answer has to be both greater than 2 and also less than 2.5. Solving an or inequality, then I'm switching over to our second type. We're still going to do the same thing, solve just like a simple inequality. However, it's like we're solving 2 of them now. So we're going to solve them independent of each other. You see now it's like having a squiggly right through the or. We've got 2 separate pieces. I'm going to divide this one, both sides, by 5. And that's going to leave me with x is greater than, and then we'd end up with 3.2 for that. Or, I'm going to bring down my or. If we do the same thing, divide by 5, x is less than or equal to 2. Okay, so it could be either one of those. So that's how we solve them. One, we solve doing like there are 3 sides. Same inverse operation rules apply. Dividing by negative still flips your symbol. And the or, it's like we just solved 2 different inequalities. So it's kind of like 2 problems in one. Again, the same negative dividing by or multiplying by a negative number still applies. Okay, finally then graphing those. So same idea as a simple linear inequality from part 1. We're going to draw our number line. We're going to choose either open or closed circles for the same reasons. Open would be less than or greater than. Closed would be greater than or equal to or less than or equal to. So remember the equals to part for our closed circle. And then we're going to shade, more often than not, the shared section accordingly. Okay, so if you look at our answer from the previous slide, 2 is less than or equal to x is less than 2.5. I'm going to draw my number line. Now, important numbers here, I'm going to say are 0. We can always start with that. We could put -1, but we don't really need to. Now we're going to do 1, 2, and 3, and that's really more than we need. At 2 here, because of this piece, we're going to have a closed circle. So I'm going to draw a closed circle at 2. And because of our less than symbol here, this needs to be an open circle. So I'm going to draw an open circle about halfway between. And then numbers that are in between 2 and 2.5 means I'm going to shade the shared section, or the section that is in between the two of them. And that's going to be right here. That would be our graph of our solution for an and inequality, and particularly this and inequality. Okay, or inequality, then same basic idea, draw a number line. We're going to choose open or closed circle still, but now we're going to share the unshared sections because they point away from each other. So again, let's start by drawing our number line. And I'm going to put 0 here, and then 1. Scroll down a little bit, 2, 3, and 4. I can put -1 if I want, but don't really need to. So less than, or I'm sorry, greater than 3.2. So I'm going to go just to the right of 3 and put an open circle because we have greater than. And then I can think about this one. Since it's or, I can shade them independent. If it's or greater than 3.2, that means values to the right of 3.2. And now I'm going to do the other one, less than or equal to 2. So the or equals to piece, remember, tells me to shade in, fill in the circle. And then I'm going to shade values that are less than 2 all the way to the end of the number line, and it'll keep going. All right, so that is how we solve and graph solutions to compound inequalities. So remember, there is or and. And is going to have basically a shared section that we graph, and we do operations to all sides. Usually there's going to be 3. And or, it's kind of like solving 2 different linear inequalities, graphing them on the same number line, graphing them on the same number line, and they're almost always going to be the unshared sections pointing away from each other. Okay, we'll see you next time.